For this section, we are working with evaluating functions. So the one thing that we will see is function notation. We're going to be using this notation. So instead of an equation that looks like this, y equals 3x plus 1, where x was the input and y was the output, you're going to see this notation. F of x equals 3x plus 1, where x is the input and f of x is the output. More specifically, we are replacing y with f of x. So everywhere we see y, we're going to replace f of x. So let's see what this looks like. So let's look at a quick example of a function we're familiar with. If they asked us to solve for y when x is 2, well, our steps would be to plug in 2 for x and simplify. And we would get y equals 4. So we know that when x is 2, y equals 4. How does this look in function notation? Well, for starters, our equation would look like this. And instead of having to say solve for y when x is 2, you would see this notation. That means everywhere you have an x, you're replacing it in that function with 2. And then you would simplify the same way. And it's a much cleaner way of saying when x is 2, y is 4. We just read it as f of 2 equals 4. So here are some quick ways of practicing evaluating these functions. If they wanted us to evaluate f of 1, that means find that y value when x is 1. Everywhere we see an x, we replace it with 1. We treat those x's like placeholders. So we can think of it like that. And then everywhere we have those placeholders, we plug in what we're trying to evaluate. So in this case, it would be 1. And then our next step would be to clean it up until we got our answer, that f of 1 is negative 1. We can really plug in anything into our function. It's like a machine. So even if they wanted us to evaluate f of 2p, I would treat those x's and f of x as placeholders and plug in my 2p everywhere I had that, and then I'd simplify. And that would be f of 2p. Pretty much anything can go into our function machine. It might not make sense, but it follows that same format. I could plug cows in for my x's. I'm just using those x's as placeholders. If we look at question 1, here are a few values that we're asked to evaluate. So let's take a look at a few of these. Keeping in mind that those x's are placeholders, and so for every problem, we're just going to plug in what we're asked to evaluate. So for A, our function would look like this for f of 6. And then we would simplify to get our response, our end result. F of 6 is 3. I would do the same thing for B. I'm asked to evaluate f of negative 2. So everywhere I have an x, I'm replacing it with negative 2 and then simplifying it. So we would get that f of negative 2 is negative 13. If we look at the problems 3 through 6, we're given different functions, f of x, g of x, and h of x. Let's look at 6. Now we're asked to find x if g of x is 30. So in this case, we're replacing 30 for g of x. So now we have to solve for x. So we add 3 to both sides, giving us 33 equals 3x. Next, we divide both sides by 3, giving us that 11 equals x, or we could write that as x equals 11. Here's how we get Desmos to help us out. You'll notice in that equation we have y equals x squared plus 3x minus 1. Well, we can go right up there and replace y with f of x. And now that's helpful because if I go down to the next row, I can ask to have Desmos evaluate any x value. And it tells me what that f of x is. Also, if I go here to the plus button, I can add a table. And if I scroll up, I can replace y with f of x, and I typed the 1 in as well. And that's useful if we want multiple f of x's. Lastly, let's look at evaluating functions at specific x values when you're given a graph. So here is our graph of f of x. And you'll see over to the left that we want to see what f of negative 1 is. So on our graph, we're going to go to the negative 1 value, and we're trying to identify what is that y value when x is negative 1. And we can clearly see that that y value is 0. So now let's look at a different one. How about f of 2? We want the y value when our x is 2. And if you're looking, right there is our x equals 2, and on our graph, that looks to be a y value of negative 3. And the third one is 4. So we go through the same process. We're locating the y value when x is 4. And that gives us 5. So now the next two we're working in reverse. We want to find x when our y, our f of x, is 0. So that means that we want the x values that intersect our graph at 0. And that would be at more than one point. It would be here and here. So what are those x values? Well, one we had already discovered was negative 1. And the second one is 3. So there are two x values where f of x is 0. And the last one is asking what's the x when f of x is negative 4. So now we look at the y value of negative 4, and we can see that that's right there, and we're trying to locate what x value has that y value of negative 4. And that is x equals 1.